function? Does it pass the vertical line test? Yeah, so this is a function. Okay, so we checked using a table of values and using the graph. So when you have a graph, that's when you use the vertical line test. All right, let's look at the next one. Let's check with a table. Okay, picking an x value of, let's say, 1. What would y be? Well, y is going to equal, oh, this is weird, y squared equals 1. Well, to solve for y, we're going to take the square root of both sides, plus or minus, and then we get y equals plus or minus the square root of 1, so y equals plus or minus 1. Okay, look what happened. My x value has 2 different y values. For each x, there's supposed to only be one y value. This one says, when x is 1, we have 2, positive 1 and negative 1. So this one breaks the rule. Okay, so this is not a function. If you were going to check the graph for this, if you wanted to plug that into your calculator, you'll notice it'll come out to being something like that. Okay, and if I dropped a vertical line, it would hit more than one place. Let's try y cubed equals x to see if this is a function. Okay, x, y cubed equals x. All right, let's pick 1. See what happens. So y cubed equals x. Cube root of both sides. Oh, interesting. Now remember, when we do the cube root, we don't have to do the plus or minus sign. Oh, that's supposed to be a 1. Sorry. So y equals the cube root of 1, which y equals 1. So there's only one value. In fact, every time I pick a value for x and I solve for x, because when I take the cube root, I'm not going to be adding in the plus or minus symbol, I will always end up with just one answer. Okay. So, knowing that whatever value I pick for x, I will always end up with one value for y when I solve, I know this is a function. Okay, and if you want a quick hint on what the graph of this looks like, it looks something like that, okay, which also passes the vertical line test. All right, let's take a look at D. So remember, we're looking for each x, there should only be one y. I'm just going to go ahead and plot these values so you can get a clear idea. So here's 1, and its matching value is 2. This one says we have 2 and 3. This one then says we're supposed to have 1 and 1 and 3, but I already said we're supposed to have 1 and 2. This is telling me I also have 1 and 3. But this breaks my rule for functions where each x should only have one y value. This is not a function. My x value has 2 separate y values. This is not a function. Remember, each x must have only one y. Think of a marriage. It's not legal to have more than one spouse. Each x must have one y. All right, and let's take a look at this. Same idea here. For each x, is there only one y value? Yeah. Oh, you might be concerned though. But notice the y is doubled here. So the y value of 1 actually has 2 x values. But remember, that's not a problem. For us, it's only for each x. There's only one y. Okay, so the other way around, that's not how we check a function. For a function, for each x, there's only one y. Okay, this one passes the definition that for each x value, we only have one y. So this is a function. Okay, all right, and that's that for this. Sorry, I don't have the homework page attached to this, but there is a written homework for section 2.2, which is going to be due by the end of the week. So please make sure to ask me if you have any questions about that.